This is the question of 2014 October-November paper 1-1 and the question number is 16. So this time I have done it in my handwriting. So it says a projectile is launched at 45 degree to the horizontal as shown here with the initial kinetic energy E. So that means when the projectile was launched like this, the energy that it possessed here was the KE was equal to E. Now the question asks that assuming negligible air resistance, that means it is a pure projectile without any air resistance, what will be the kinetic energy of the projectile when it is at the highest point? So we have to find the kinetic energy here. So the choices are ABCD. One is 0.5, one is 0.71, one is 0.87 and the other is total E. So first we have to remember that if the velocity here is U, if the launching velocity here is U, the horizontal velocity or the horizontal component will be equal to U cos of theta if this angle is theta, and this vertical component will be equal to U sine of theta. Now when it reaches the highest point, here the horizontal component remains as it is, it does not change, so it's equal to U cos of theta, and the vertical component is 0, totally 0. So that means the KE here, if the KE here is equal to E, we must have the kinetic energy. So let's do it here. If the KE at the beginning point is E, we must have this E should be equal to 1/2 mu square. Let us name it as equation number 1. Then if I shift it a bit like this, then if I have to find the KE here, so let me see, this is E final, that's equal to 1/2 m, and the velocity here is, it is only U cos theta. Since there is no vertical component but there is only the horizontal component, its velocity here is U cos theta and then it is square. So it should be equal to 1/2 m U square cos square theta, and that's equal to, since this factor is equal to E, it should be E cos square theta. So if the initial energy here is E, the KE here will be E cos square theta. Now what it says is theta is equal to 45 degree. So that means our E final will be equal to E cos square 45 degree. That's equal to E into 1/√2 square equal to E into 1/2, which will be equal to 0.50 into E. So this answer is in tally with choice number A. So choice number A should be the correct answer.